Welcome to decomposition of partial fractions. What we're going to do today is we're going to take a rational expression and rewrite it as what we call partial fractions. So usually we kind of work in this direction. Usually we take two partial fractions, add them together to create one rational expression. But what we're going to do today is we're going to go the other way. We're going to take a rational expression and break it up into what we call partial fractions. Here are the steps to decompose the partial fractions. Go ahead and write these down, and then we'll go through and kind of talk about them as we do a problem. So just to go through these: 1, factor the denominator. 2, expresses a sum of a and b. I'll talk about what that means. 3, we want to multiply by the common denominator. Then we want to choose values for x. The hint on this is we want to choose excluded values, and I'll talk about why that is. And then we want to solve the equations. And then the 6th one is to rewrite as a sum of fractions. So you might need to pause to write those down, but we're going to go ahead and move on here. So here we go. We're going to take this rational expression and rewrite it as a partial fraction. So the first step was to factor the denominator. So we're going to take the denominator and factor it. We have x minus 5 and x plus 2. You can check that and you'll see that that factors correctly. We're going to rewrite as an expression as sum of a and b. So we're going to take the original, which is 6x minus 2, over the factored form of the denominator, x minus 5 and x plus 2. And we're going to rewrite this. We don't know the numerator, so we're going to call that a. And then one of the denominators will be one of the factors, so x minus 5, plus b, once again we don't know that, over the other factor of x plus 2. The third step is then to multiply by the common denominator. So we want to get rid of all the denominators. So we're going to take this entire expression and multiply by the two factors of the denominator, which were x minus 5 and x plus 2. So once again, each part gets multiplied by that. So as we multiply, the x minus 5 would cancel with the x minus 5, the x plus 2 would cancel with the x plus 2. So everything would cancel on that first one. So that would leave us with 6x minus 2. Then on the next one, the x minus 5 would cancel with the x minus 5, but then we'd still have an x plus 2. So once that cancels, it'll be equal to a times just the x plus 2, because the x minus 5 is canceled, and then this x plus 2 will cancel with this x plus 2, and we'll be left with plus b times x minus 5. And so now we've multiplied by the common denominator, and now this is where we want to choose values of x. Technically you can choose any values for x, plug them in, and you would get an equation with two unknowns, a and b. But if we choose wisely and we choose the excluded values, starting with x equals negative 2, and we plug it in, what we find out is it's going to cancel one of our variables, a and b. So we'll say 6 times negative 2 minus 2 is equal to a times negative 2 plus 2, that's where you're going to get that cancellation, plus b times negative 2 minus 5. And we simplify this. This will give you negative 14 is equal to a times 0, so that's going to cancel, plus b, not 5, plus b times negative 7. So what we're left with is negative 14 equals negative 7b, divided by negative 7, and b is equal to 2. And then we'll do the same thing with the other excluded value of x equals 5. And when I'm talking about the excluded values, I'm talking about the values in the denominator that are your restrictions. And so those are 5 and negative 2. So now we'll plug in 5. 6 times 5 minus 2 is equal to a times 5 plus 2, plus b times 5 minus 5. That one will cancel. So you'll be left with 30 minus 2, which is 28, is equal to a times 7 plus b times 0. So 28 is equal to 7a divided by 7, and a is equal to 4. So we have now found the values of a and b. So the last step is now to take this and to rewrite. So, and I want you to not just tell me what a and b are, I want you to rewrite it as a partial fraction. So we're going to go back to the original, 6x minus 2 over x squared minus 3x minus 10 is equivalent to, now a is 4, so we'll say 4 over x minus 5. And I'm going right back to this. I'm plugging in a and I'm plugging in b. So 4 over x minus 5 plus b, and that's 2 over x plus 2. So when you're done, I should see that whole thing right there. Okay, so we've created the partial fraction that gave us the rational expression. And that's all you need to do for this lesson. I'm going to give you one more problem to take a look at. I would pause the video and see if you can go through the process on your own. There's nothing wrong with having those steps in front of you as you go through this process. So once again, let's you can pause it, or you can kind of watch again how this works. So first step, factor the denominator. X plus 3 write that again. So x plus 3 and x minus 2. So we'll take 12x plus 11 over x plus 3, x minus 2, and that's equal to a over x plus 3 plus b over x minus 2. And now this whole thing gets multiplied by the common denominator, x plus 3 and x minus 2. And remember, the reason you're multiplying by the common denominator is so that you get the denominators to cancel. So that will leave us with 12x plus 11 is equal to a times x minus 2 plus b times x plus 3. 12x plus 11. Oh, oops. So now we want to pick our values. So we'll pick the excluded values of x equals 2 and x equals negative 3. So if we plug in 2 and solve, we know this is going to be a times 0 plus b times, if we plug 2 in, 2 plus 3. So 24 plus 11, 35 is equal to 5b divided by 5, and b is 7. And now we'll do the same thing with the other excluded value. 12 times negative 3 plus 11 is equal to a times negative 3 minus 2 plus negative 3 plus 3 is 0. So negative 36 plus 11 would be negative 25. And then that will be equal to negative 5a. Plus 0 and then divide by negative 5, so a is equal to 5. And then we just rewrite. So we'll take the original 12x plus 11 over x squared plus x minus 6 is equal to a, which is 5 over x plus 3, plus b is 7 over x minus 2. And so there you go. Once again, taking a rational expression and rewriting it as partial fractions. And that is it. Thanks.